Hi everyone, a very good morning. I am Mr. Chu and I'm going to show you very important ideas on how to handle questions on kinematics. The four equations of kinematics are these four over here. A equals to v minus 0 upon t, s equals to ut plus half a t squared, and the other two equations that you see on the board. Now the challenge is always how to use the equations. Remembering them is not difficult, but how to use them and how to use them correctly is very important for us to understand. Now, if we are given a question, say for example, a car travels at 25 meters per second, slows down to 10 meters per second in 50 meters. Find the deceleration and the further distance the car travels before stopping. Okay, so how are we going to handle this question? Now, it is actually very simple if you have a mechanism, you have an approach, you have a structure of handling problems. So if I suggest you to remember this thing called STUVA, it is actually the 5 variables that are in these 4 equations over here. S being for displacement, time, initial velocity, final velocity, and acceleration. So how are you going to apply this? What is this about? And how are you going to apply this to help you solve the question? First, you need to know which equation to use, right? So if you don't know which equation to use, it is very difficult for you to even start. So you know, I guess you know that this is a kinematics question, so that helps to save a lot of time instead of identifying which physics topic you're talking about. So the question is, what information do we know and what do we want to find? Let's take a look. You want to find the deceleration. So this is what you want to find. And then you know the initial velocity, which is known. You need to know the, you're also given the final velocity over there, 10 meters per second. And you also know the displacement. So the only thing that you don't have any information about is time. Now this is the part which is interesting. If you try to find the equation that connects these 4 variables, it is actually more difficult from my experience than to find the equation that doesn't have the variable that you are not interested in, which is time. Take a quick look. Which is the equation over here that doesn't have time? Bam. Very simple. It is this one. So it is easier for you to identify the equation that doesn't have the variable that you're not interested in than to find the equation that has 4 variables. Alright? Because you're handling one instead of 4. So this is a simple trick that helps you to go and zoom into the equation that you need faster. So the equation over here, v squared equals to u squared plus 2as, you'll find that this is final 10 squared, 25 squared, plus 2 times a, which is what you want to find, times 50. So a will be equals to 10 squared, which is 100, minus 625 divided by 100, which is going to be 525 divided by 100, minus, and therefore this is equals to minus 5.25. Now, before you dismiss the negative sign, the negative acceleration means it is a deceleration. Okay? But I'd like to elaborate a little bit more on what I mentioned about that, which is negative acceleration means deceleration. We need to be careful about that. What it means by negative acceleration and positive acceleration. So, before I go on to the next part of this mini lesson, this micro lesson, I'd like to recap that in order to help you find out which equation to use, STUVA, it applies for projectile motion as well. So this is something that is very useful that I highly recommend you to remember this approach. STUVA, identify the variables that you have, that you want to find, identify the variable that you don't have and you don't really care about, and then identify the equation that doesn't have the variable that you don't care about. Alright, that's much faster. Now, I'd like to elaborate a little bit more on the negative acceleration and positive acceleration because that's where mistakes are made. Because if you substitute the wrong sign, things are gone. Alright, marks will be gone. So let's take a look at this very simple motion over here. This is point 1, this is point 2, point 3, point 4, and point 5. And I'd like to show you this using this position. 1, 2, 3, 4, 5. And for the purpose of this discussion, I'm just interested in the sign of the displacement, velocity, and acceleration. So let's take a look. Of course, we love to go up, right? So we take upwards to be positive. For this position, easy for you to determine that the velocity is going up. So it's positive. At the highest point, velocity is 0. At this position, this is negative because it's going down. 4 going down, 5 also going down. Alright, so this displacement over here is going to get more interesting. Displacement over here is upwards, so it's positive. From here to here, it is positive. Now this is the interesting part. It is going down, but it is still displaced upwards from the original position. So it's still plus, 0 displacement, and negative. Now this is, we move on to acceleration, and this is very interesting. Acceleration is always pointing down. Now, in order to help you understand why is it down, where is the only force acting on this object pointing? Down, right, which is the weight. So if the weight is the only force pointing down, is the only force acting on the object, and is pointing down, the downward force will be the net force, and therefore the acceleration always follows the direction of the net force. And that's why it is always pointing down. Now what I'd like you to focus on are two positions. This position, which is position 1, and this position. Look at the motion on this object. The acceleration is negative. The velocity is positive. So at this position, it is decelerating, it is slowing down. However, take a look at this. Negative acceleration, negative velocity. At this position, is it slowing down? No, it is speeding up. So whether it is slowing down or speeding up has nothing to do with the sign of the acceleration. It has more to do with whether the signs of the velocity and acceleration are in the same direction. If it is the same direction, even if it is a negative acceleration, it is positive. What I mean is, it is accelerating. If it is negative acceleration and positive velocity, it will be slowing down. So I can have a positive acceleration and a negative velocity, and the object will be slowing down. So that's why it is very important for you to understand that negative acceleration doesn't mean deceleration. Neither does positive acceleration means acceleration. You have to look at the relative direction between the velocity and acceleration. Now the reason why I'm emphasizing this is because it's going to be linked to the next video that we're producing, which is on the lift question in forces. If I got an object that is going down, a lift that is going down, and slowing down, using what you learned over here, what do you deduce about the direction of acceleration? The object is going down and slowing down. So if it is slowing down using what we learned over here, the acceleration must be opposite to the direction of velocity. So it is going up. Likewise, say for example, if the person is going up but slowing down, if the person is going up but slowing down, acceleration must be opposite direction to the velocity. So it is this direction. Therefore, it is very important for you to understand this basic idea. Otherwise, it will cause issue in forces, and you'll think that it is issue with forces, but actually it is issue with understanding of basic kinematics. So it is with this that I hope that you get a very quick understanding of how to use the equation and the fundamentals of motion, that displacement, velocity, and acceleration. If the velocity is going up, it doesn't mean that this will be always positive. Alright, this is a very intuitive generalization that we always make, that whenever this is negative, both must be negative. Not necessarily true. You've got to distinguish displacement, velocity, acceleration, draw a big fat positive, whether it's upwards positive or downwards positive, make reference to that. And very important, velocity positive, acceleration negative means slowing down. Okay, if it is opposite direction, it is slowing down. Same direction, it is speeding up. And when applied to a question of forces, they may not tell you whether the acceleration is positive or negative, but knowing the velocity direction and the state of motion, whether it's slowing down or speeding up, you can deduce the direction of acceleration, which is important for you to do to write the right equation for the Newton's second law. Alright, okay? So I hope that you gathered something from this micro lesson, and I hope you gained something from it. Thank you.